Hello friends, welcome back to my YouTube channel. In today's video lecture, which is part number 10 of my discussion on adsorption, I will discuss a numerical example that is based on the BET, Brunner-Emet-Taylor adsorption isotherm. This is numerical example number 2. Numerical example number 1 I had discussed in part number 9, and that was based on the application of the Langmuir adsorption isotherm. So this numerical example, it is based on the application of the BET adsorption isotherm, that is Brunner-Emet-Taylor adsorption isotherm. So let us begin the discussion. First, we will look at the numerical statement. Spherical particles of 15 nanometer diameter and density of 2290 kg per meter cube are pressed together to form a pellet. The following equilibrium data was obtained for adsorption of nitrogen at 77 Kelvin. So you have the equilibrium data that is given to us. In this case, Pn2 is the partial pressure of nitrogen in the gas phase, and Pn2 naught is its vapor pressure at 77 Kelvin. The density of liquid nitrogen at 77 Kelvin is 808 kg per meter cube, and the area occupied by one adsorbed N2 molecule is 0.162 nanometers square. The Avogadro number is 6.02 into 10 to the power 26 molecules per kilomole, and we have to find out the surface area. We find the surface area of the pellet. So let me first tell you, I am discussing the same numerical. I had discussed this, but I had discussed this numerical in my previous video. But in that case, I had discuss the application of Langmuir adsorption isotherm. Now, in this particular video lecture, let us understand how to find out the surface area of the pellet by using the Brunner-Emet-Taylor, that is BET adsorption isotherm. So let us first understand what is given to us. So you have a adsorbent pellet is formed, and how it is formed? It is formed from small spherical particles which has a diameter of 15 nanometer and a density of 2290 kg per meter cube. And with this pellet, the following adsorption data was obtained. So one parameter that was studied or that was varied is the ratio of pressures, ratio of partial pressure of nitrogen to the vapor pressure of nitrogen at 77 Kelvin. And the other parameter that was studied is meter cube of nitrogen that was adsorbed per kg of solid into 10 to the power 6. So different values for this entire term, they were obtained. So this is the equilibrium data. And the density of liquid nitrogen at 77 Kelvin, it is given to us, it is 808 kg per meter cube. And when the nitrogen molecules, one nitrogen molecule goes on the surface of the adsorbent, it is going to occupy an area of 0.162 nanometer square. Avogadro number is given to us. It is 6.02 into 10 to the power 26 molecules, number of molecules per kilomole. And with this information, we are supposed to find out the surface area of the pellet. So let us move ahead. First, we will note down what is given to us. In this case, the adsorption task is we need to adsorb or it is adsorption of nitrogen at 77 Kelvin. The adsorbent pellet that is used in this case, it is to be formed from spherical particles, and for these particles we know the diameter of each particle is 15 nanometer, and if I convert it to meter, it will be 15 into 10 to the power minus 9 meter. Then density of this particle is also known to me or given to me. It is 2290 kg per meter cube. When nitrogen is on the surface of the adsorbent, then for that particular case, its density is given to us. I'm going to denote it as rho L. So rho L is 808 kg per meter cube. Area occupied by one adsorbed nitrogen molecule, that is given to us. I'm denoting it as AN2, and it is 0.162 nanometer square. It is given to us. Then Avogadro number is given. It is I will denote it by capital N. So capital N is 6.02 into 10 to the power 26 molecules per kilomole. That means each kilomole of nitrogen is containing 6.02 into 10 to the power 26 molecules of nitrogen. Then the equilibrium data is given to us. In the gas phase, this values for this parameter, this ratio are given to us. Pn2 by Pn2 naught, partial pressure of N2 in the gas phase, and Pn2 naught is vapor pressure of nitrogen at 77 Kelvin. Then on the surface of the adsorbent, this values for this parameter, they are given. Meter cube of nitrogen adsorbed per kg of solid into 10 to the power 6. So we have values for this entire term. I will shortly tell you how to use this. So with all this information, what are we going to find? We are going to find the surface area of the adsorbent pellet. So this is the given data, and by using this given data, we will find out the surface area of the adsorbent pellet. So let us move ahead. The BET adsorption isotherm, I have derived the equation for this isotherm in one of my previous videos. I am giving link to the entire playlist of my videos on adsorption. So the equation is Pa upon Pa naught divided by 1 minus Pa upon Pa naught into V is equal to B minus 1 upon B into V bar into Pa upon Pa naught plus 1 upon B into V bar. So in this case, Pa is the partial pressure of A. In this case, we have A is nitrogen, partial pressure of A in the gas phase. Pa naught is the vapor pressure of A at the constant temperature, vapor pressure of nitrogen, and then V is the volume of A adsorbed on the surface of the adsorbent. It is volume, simple volume, meter cube. For example, it is meter cube of nitrogen adsorbed on the surface of the adsorbent. Then V bar, it is volume of the gas adsorbed on a unit area of each layer. So if you remember in BET, as per the BET adsorption theory, multiple layers of adsorbed molecules they can form on the surface of the adsorbent, and in each layer, on a unit area of each layer, V bar is the volume of the gas that gets adsorbed. So significance of V bar in this equation is it is the volume of the gas adsorbed on a unit area of each layer. Then B, it is a constant. So let us again look at, we are going to modify it. so that we are going to modify the BET equation so that we can use for this particular example. So you have the equation. I have again rewritten that equation. Now this equation, we can rewrite it for unit mass of adsorbent. The equation will remain same, but some of the terms involved in that equation, they will have a different meaning. Let us understand. So it can be written for unit mass of adsorbent. So if you are doing that, in that case, V bar will be volume of adsorbed nitrogen for unit mass of adsorbent when the adsorbed layer covers the entire surface of the adsorbent. So in the original equation, V bar was the volume per unit area of each layer when that layer was complete on the surface of the adsorbent. Now we have rewritten it, and in the new form, V bar would be the volume of adsorbed N2 per unit mass of the adsorbent when the adsorbed layer covers the entire surface of the adsorbent. So now it is meter cube per kg of adsorbent. V again, it would be the volume of adsorbed N2 per unit mass of adsorbent. So now here, instead of meter cube, V will be meter cube per kg. And then A is N2, so that's why I have rewritten this equation. So you have Pn2 by Pn2 naught divided by 1 minus Pn2 by Pn2 naught into V, that is equal to B minus 1 upon B into V cap V bar plus B into V bar into Pn2 by Pn2 naught plus 1 upon B into V bar. And now we are going to use this data, or we are going to use this equation to plot the required graph, and then from a slope and intercept of the graph that is obtained, we are going to find out the area of the billet. So let us move ahead. So now the rewritten equation is Pn2 by Pn2 naught divided by 1 minus Pn2 by Pn2 naught into V is equal to B minus 1 upon B into V bar into Pn2 by Pn2 naught plus 1 upon B into V bar. So this equation, how can you use, or this equation, it is going to represent a straight line. How? If you plot Pn2 by Pn2 naught divided by 1 minus Pn2 upon Pn2 naught into V on the y-axis, that is, you are plotting this term on the y-axis and you are plotting this term on the x-axis, Pn2 by Pn2 naught. So you are going to get a straight line. Slope of this line would be giving us B minus 1 upon B into V bar. That is, we can get V bar if you know the slope of this line, and you also get an intercept which is 1 upon B into V bar. So here also you can get V bar. So you get basically two equations, and there are two unknowns, B and V bar. So you can get those two unknowns, and then after getting V bar, we can find out the area of the billet by the method, or by a method that was used in the previous numerical in part number 9. Okay, so we have the equilibrium data that is given to us. So we have different values for Pn2 by Pn2 naught, and then corresponding values for meter cube N2 per kg of solid into 10 to the power 6. So values for this entire term, they are given to us, and we are going to plot this graph. On the y-axis, we are going to plot Pn2 by Pn2 naught into 1 minus Pn2 by Pn2 naught into V. So values for this term, we have to get those values. On the y-axis, Pn2 by Pn2 naught, the values are already known to us. Now let us understand how to use the values given in the second column. So these are values for V, that is meter cube of nitrogen per kg of solid into 10 to the power 6. So for the first reading, the value of this entire term is 66.67, which means V, that is meter cube of nitrogen per kg of solid, is 66.67 into 10 to the power minus 6. So in this way, all values will have to be multiplied with 10 to the power minus 6 in order to get V. Now let us calculate this term for the first reading. So it is Pn2 by Pn2 naught divided by 1 minus Pn2 by Pn2 naught into V. Pn2 by Pn2 naught for the first reading, it is 0.1. So it will be 1 minus 0.1 divided by 1 minus 0.1 into 66.7 into 10 to the power minus 6 V for the first reading. So this comes out to be 1666, that is 1666. So in this way, you have to get the values for other readings. And I have got those values. I will be taking those values in my discussion. So I have got values for all the entries. And now I'm going to plot these values. Okay, so let us plot the graph. So we will be plotting this values on the y-axis and these values on the x-axis. So on the x-axis, we are going to plot Pn2 by Pn2 naught, and on the y-axis, we are going to plot Pn2 by Pn2 naught divided by 1 minus Pn2 by Pn2 naught into V. So if I plot, I'm going to get this curve. Now let me tell you, I have, in order to consider the straight part of the curve, I have just used values up to 0.7 or 0.6. So if I plot values beyond 0.6, I'm going to get a curve. But we need to consider a straight line for using the BET adsorption isotherm. So the straight part of the curve is up to values 0.6, and accordingly I have used those values. Then I will extend the line so that it meets the y-axis, because I want to get the intercept on the y-axis. I need that in my calculation. So I have extended it with a straight line so that I get the intercept on the y-axis, and you can easily see in this case the intercept comes over here, and as per my scale the intercept comes out to be 100. So intercept made by the adsorption isotherm on the y-axis is 100 for this case. So intercept is 100, but intercept is nothing but 1 upon B V bar, that is equal to 100. That is 1 upon 100 is equal to B V bar, that is B V bar is equal to 0.01. So the intercept gives me the value of this product, B into V bar. Now let us use the slope. For finding out the slope, I am considering this point which has coordinates of 0.2 and 3324, and other point which has coordinates of 0.1 and 1666. So slope, geometrical slope is y2 minus y1 divided by x2 minus x1. Y coordinate of one point minus y coordinate of another point divided by x coordinate of the previous point minus x coordinate of this point. So that is what I have done over here. Slope is equal to 3324 minus 1666 divided by 0.2 minus 0.1. That is slope is equal to 1658 divided by 0.1. That is slope is equal to 16580. but slope is B minus 1 upon B V bar, that is equal to 16580. BV bar, we have calculated it from the intercept. BV bar is 0.01. So let us use that value. So B minus 1 upon 0.01 is 16580. Now our aim is to get B. So we will continue with this calculation. So B minus 1 upon 0.01 is 16580. That is B minus 1 is 16580 into 0.01. That is B minus 1 is 165.80. That is B is equal to 165.80 plus 1, which gives us B as 166.80. Now we are going to use this value of B to get the value of V bar. So we have got, this intercept is 1 upon B into V bar is equal to 100. B is 166.80. We just got that value. So let us use that value. Therefore, it will be 1 upon 166.80 into V bar is equal to 100. That is 1 upon 166.80 into 100 is equal to V bar. That is V bar is equal to 59.95 into 10 to the power minus 6 meter cube per kg. And now we are going to use this value of V bar to get the surface area of the adsorbent. So let us move it. So we got a V bar as 59.95 into 10 to the power minus 6 meter cube per kg. So this is nothing but the volume occupied by a monolayer of N2 molecules that covers the entire surface of 1 kg of adsorbent pellet. So this meter cube of nitrogen, it is occupying the entire surface of 1 kg of adsorbent pellet. So if you look at the adsorbent, 1 kg of adsorbent I have shown, and then entire surface area of this adsorbent will be occupied by this blue colored nitrogen molecules, N2 molecules. Now let us convert this V bar into kg per kg, because ultimately I will have to get, or my aim is to get number of molecules of N2 that occupy the surface of the adsorbent when the layer is complete. So for that, first I need to convert V bar to kg per kg. So V bar, it is 59.95 into 10 to the power minus 6. So in order to convert it to kg per kg, I will have to multiply with the density of liquid nitrogen which is given to us. So this is meter cube per kg, and you have to work on this. So you have meter cube per kg, and if I multiply it with the density which is given to me, meter cube is going to get cancelled, and I'll be getting kg per kg. That is what I need. So that's why I have multiplied it with the density. So let me first erase this so that I can complete the discussion. Okay, so that is V bar. V bar is equal to 59.95 into 10 to the power minus 6 into 908 kg per kg. 908 is the density of liquid nitrogen that is given to us. So that gives us V bar as 0.054 kg per kg. So V bar comes out to be, V bar in this case comes out to be 0.054 kg per kg. Now next, in order to get number of molecules, I will have to convert kg per kg, V bar from kg per kg to kilomole per kg. So for that, what I will do, it will be V bar is equal to 0.054. In order to convert kgs to kilomole, I will have to divide with the molecular weight of nitrogen. So V bar is 0.054 divided by molecular weight of nitrogen. Now it will be in kilomole per kg. That is V bar is equal to 0.054 by 28. because molecular weight of nitrogen is 28. So now this will be 0.054 by 28 kilomole per kg. That is V bar comes out to be 0.001928 kilomole per kg. So in this way, we convert V bar to kilomole per kg. Now let us move ahead. We got V bar as 0.001928 kilomole per kg. That means the monolayer will contain 0.001928 kilomole of nitrogen per kg of adsorbent pellet. Now let us convert V bar from kilomole per kg to number of N2 molecules per kg. So for that we are going to use the value of Avogadro number. So Avogadro number is given to us. It is 6.02 into 10 to the power 26 molecules per kilomole. That means in 1 kilomole of nitrogen, there are 6.02 into 10 to the power 26 molecules of nitrogen. Now the task is to find the number of N2 molecules that will be contained in 0.001928 kilomole of nitrogen. So let us so we will find the number of molecules, N2 molecules that will be occupying the layer, the surface of the adsorbent. Area required for one nitrogen molecule is known to us. So from this we can easily find out area required by all the nitrogen molecules, which will cover the entire surface area of the pellet, and that is nothing but the surface area of the pellet. So let us move ahead. So converting V bar to number of N2 molecules per kg, we are doing that. So we have Avogadro number 6.02 into 10 to the power 26 molecules per kilomole. That means in 1 kilomole of nitrogen there are 6.02 into 10 to the power 26 molecules of nitrogen. The task is to find the number of N2 molecules in 0.001928 kilomole of nitrogen. We know that 1 kilomole of nitrogen is equivalent to 6.02 into 10 to the power 26 molecules. That is 1 kilomole of nitrogen contains 6.02 into 10 to the power 26 molecules of nitrogen. So in 0.001928 kilomole of nitrogen, how many molecules of nitrogen will be there? Let me call it as Y. So I have to get the value of Y. So for that, from this equivalence I can write this equation. I will use cross multiplication. So Y into 1 that is equal to 0.001928 into 6.02 into 10 to the power 26. So this will be equal to, that is equal to 0.001928 into 6.02 into 10 to the power 26. So that is what I have. Then from this equation I can get this equation for Y. Y is equal to 0.001928 into 6.02 into 10 to the power 26 divided by 1. That gives me Y as 1.16 into 10 to the power 24 molecules of N2. That is, on the surface of the adsorbent, when it is completely covered by monolayer of the adsorbent, monolayer of the nitrogen molecules, 0.001928 kilomole of N2 in that case is containing 1.16 into 10 to the power 24 molecules of N2. So we got 1.16 into 10 to the power 24 molecules of N2. These molecules forms the monolayer that covers the entire surface of 1 kg of adsorbent pellet. That is, these molecules, these blue colored nitrogen molecules, the number of these molecules is 1.16 into 10 to the power 24 molecules. So area occupied by one adsorbed N2 molecule, this is given to us. It is AN2 is 0.162 nanometer. Therefore, area occupied by this many molecules, 1.16 into 10 to the power 24 molecules of N2 will be 80 is equal to 1.68 into 10 to the power 24. 1.16. 80 is equal to 1.16 into 10 to the power 24 into 0.162 into 10 to the power minus 18. And in order to convert nanometer square to meter square, I will have to multiply with 10 to the power minus 80. So that gives me 80 as 188,026.272 meters square. And since 80 covers the entire surface, this area covers the entire surface of 1 kg of adsorbent. Surface, this is nothing but the surface area of the adsorbent. So surface area of the pellet, surface area of the adsorbent pellet will be this much area per kg. That is 188,026.272 meters square per kg. So in this way, we get the required answer, that is surface area of the pellet per kg. So with this, I end my discussion on this particular numerical example. Here you have learned how to get the surface area of the adsorbent by using the Brunner-Emmet Teller, that is BET Adsorption Isotherm. So I hope you have learned how to get the area. If you have any doubt, you please let me know in the comment section. Thanks for watching my video. Do subscribe to my channel. Tell your friends to subscribe to it and hit the bell icon so that you will be notified as soon as I upload any new video on my YouTube channel. In my next video, I will be starting my discussion on stage-wise adsorption. So please stay with me. For now, have a nice day. Thank you for watching the video. Bye.